Hello everyone. Hopefully everyone's doing well. Um, just out of curiosity, how many of you all are here from my previous stream? I just had one earlier. It was great. It was on very quick, dirty intro to agentic AIs. Gave a quick demo and then built those. Um, just let me know if you were here from there or if you're here brand new. Either way, glad you could join today. Quick introduction. My name is Abdullah. I am currently actually a master's student studying artificial intelligence. So this is, a subject that I have very near and dear to my heart, and a lot of my time is spent doing exactly this, right? So I'm glad you all could make it here today. Hopefully, we will have a great time actually going through this entire, this two-part series of just doing satellite image segmentation using artificial intelligence. So just out of curiosity, where is everyone here from? Locations. Where's everyone tuning in from? I'm currently in Austin, Texas. Weather here is a little cold. Let me check the weather. Actually, it is 10 degrees Celsius. So not too cold, not too warm. Pretty, average temperature. Texas in the United States. It's pretty good weather. Uh, Alaska, okay. Don't think I've ever had anyone join from Alaska before. That is awesome. It is, yeah, okay, yeah, it is still pretty early over there. That's good. I'm glad you could join us today from Alaska. Uh, all right. We have more people from Austin as well. Could be neighbors from Arizona. Okay. A lot of US in this house. Anyone not from the US tuning in? All right, I guess not. Looks like we're all Americans here. I said Celsius for nothing. Just kidding. Okay. So, uh, quick overview of what we're going to be doing for these almost 4 hours that we're together. Um, we are going to first just go over what is satellite image segmentation, right? Sounds like a very complicated term, but it really isn't. Then we're going to go over how to actually get some satellite images and do a little bit of sort of pre-processing on them. So just so that we can really have everything ready for our sort of machine learning model to learn off of. We're going to do that today. And then for the next stream, we're actually going to be doing a lot more code. So today should be a little bit quicker, where we're really only looking at sort of all the cleanup and the pre-processing that goes into something like, hey, I'm trying to figure out how, the nearest one example, like tennis courts, for example, right? Um, if you have let's say if you just wanted to search, hey, like tennis courts near me, right, on like Google Maps or Apple Maps, for example, then you'd get a list of tennis courts, but usually that's based off of not what's on the ground, but based off of ratings of public places, right? They don't use, even like Google Maps, for example, does not use satellite imagery in the way that they could, right? They could use satellite imagery and actually identify each one of the buildings or each one of these like, locations and label them as, hey, this is this specific type of location, and give that to you if you say, hey, where are all the tennis courts, for example, near me? But they're currently not able to do that, or they currently don't do that. They are definitely able to if they wanted to. So that's what we're actually going to be working on today, right? We are going to be um, making something similar where we're able to see or identify different different like locations around us that have a very specific use case. Now, of course, this technology isn't perfect. It is again it is very or pretty early stages, right? It's not you know something that's been in the works for a long time. I think I was reading some of the research papers. Some of the older ones are from 2017 or so. So if like old in this case is 2017, then you can imagine it's a fairly newer, almost subject of research as well, and just a something interesting to take a look at. So I don't claim to be an expert in this either. I'm learning as well as we go on, so we can all learn together. I uh, do encourage being active in the chat as well, just because that is a great way for us to, learn from each other. If you have any questions, don't, feel free to speak out. Don't hesitate. We are in this boat together. All right. So, um, that said, let me take a look at. All right. Looks like we have somebody from Egypt as well. Okay, so we don't have only only people from the States then. That's good. All right. So we're international now. That is awesome. Okay. So really quickly, I do want to ask, how much do you all know about satellite image segmentation or image segmentation in general? So just you can just put it in the chat. What do you know about image segmentation? What do you know about, I don't know, maybe satellite imagery, even just anything that you know, just let me know, put it in the comments. I do want to see what sort of the level that we're working with here is. Okay, we have some people that said nothing. That's absolutely okay. Um, that is why we are here. Anyone who's worked with like image segmentation or something before? Computer vision, pixels, yes. A lot of computer vision and a lot of pixels are going to be seen here. Okay. Finished a basic thresholding project to separate water and land. That is interesting. That is actually something that is pretty important actually. It's in just making sort of bounding boxes to see what a very specific thing is. Uh, Someone else also in the chat said a way to differentiate between different objects in an image. That is also something that we are going to be sort of looking at as well, right? So all these are very important skills or important things to know coming in. So it looks like everyone has a pretty, or it seems like a pretty varied range of experiences. But that's great. Well, let's start from the very beginning. And it looks like, we have a pretty good group together. So really quickly, in satellite image segmentation can actually be done using like neural networks, for example. That's actually usually how it is done. And all that really is just labels different pixel regions in an image, right? Very similar to how you might do some sort of object labeling or object tracking. So a very common, I think, project that I've seen people do is just either object detection in terms of like medical objects specifically. Some of you all might have done something similar as well, where you're actually have a camera and you're detecting whether or not some sort of uh, I don't know, some surgical tools are being tracked, for example. That is a very common technique as well, or project in computer vision. I think that was also a project that I did in the past. So we're doing something very similar with actually segmenting satellite imagery. All right. So there is also this notion of annotation, right, in all of this. So normally annotation is pretty simple. You're like, hey, in like let's say the medical tools example, you're like, these are like scissors, this is a knife, this is, I don't know, like a scalpel, for instance, in like a surgical tray. Those are pretty easy to differentiate just because they usually have a very distinct pattern or a very distinct shape. But on the other hand, if you have something like a map, that's a lot more difficult because again, you have uh, a lot more things that get in the way almost, right? You have like occlusion, for example. What if you have a lot of trees around these tennis courts that you're trying to label? What if you have different lighting conditions? What if you have even different image quality? All of this is pretty all this is like important to consider when actually doing this type of work because again your end result is only going to be good as sort of the data that you give it. So a lot of open source data do exist, but again, we don't know how great they are either, and some of them might be sort of biased to one specific location, some to others. There's a lot. So yeah, there's a lot going on. So hopefully, again, if you have any questions, do let me know. But we will get right into it. Yeah, different coverage as well is definitely a thing. So image segmentation for satellite imagery specifically, or actually any image, basically assigns a label to each pixel in the image, right? So you sort of identify different regions of an image that contain the same sort of target class, and then the boundaries between all these regions. And this is actually referred to as sort of semantic segmentation. So there's other types of segmentation as well. We're going to be using, when I say segmentation, I'm just referring to semantic segmentation. So there is, let me actually pull this up. I think this might be a helpful thing to take a look at right here. So I'm just going to share an image. Percent. This right here. So this is a very commonly used image in like these specific situations. And you can see that each, like all the pixels in the image are assigned a class, right? So like the blue is all road. This is all water, right? Anything in this color, anything in this darker color is considered a building. Anything with this yellow is considered sort of vegetation, right? So this is pretty common, especially in this sort of like a multi-class labeling, right? Where you are trying to identify different things, right? So again, you can also do different types of segmentation. This is usually what people do is a very broad segmentation of, hey, this is vegetation, this is a building, this is maybe a, I don't know, like a field, for instance. Um, like Google Maps does for images. Yeah, pretty similar, exactly. They don't do this exactly. They have a slightly different technique, I think, but yeah, it is very similar. And again, there's a ton of use cases for actually segmenting roads and buildings, right? If you're trying to map sort of like urban areas, you want to make sure that they're all mapped correctly. If you want to know the vegetation percentage, some cities actually have requirements, or in the US anyways, you have like some cities that have requirements for like, hey, you have to have at least this much vegetation and this much green land on your property. So you can also do identify things like deforestation, right? Or any vegetation that could impact some sort of critical infrastructure. So all this sort of identification work is really, really useful, especially with this. And this is sort of a very quick example for well, for how these techniques can be used. So actually annotating all this takes forever, and we're actually going to go through an example of how, or an example of how the segmentation part works, right? Or annotating the segmentation part works. Again, it is very time consuming if you're trying to do something brand new. We'll do another example that is a little bit easier just because we have access to a lot of already like pre-made things. So we're just going to be calling a lot of APIs and downloading some things to take care of it for us. But if we had to do this on a much larger, much more complex scale, then it would be way more, time consuming, a lot more difficult. And that's the reason why, I think, a major reason why people don't do it as, as often as you might think, because you're like, hey, this is like a great use case. But again, there are downsides. It is very difficult. Okay, so we can actually get into how this sort of works. Let me move a few things around. Okay, yeah, like Google Maps does for images. Yeah, very similar to that. Um, this helps you not get confused in big city maps. What do you mean by that? This help me not get confused in big city maps. Dat pep. Okay. Trying to find types of roads. Interesting. All right, let me pull up everything I need for this. Again, there's a ton of examples that you all can also take a look at. I will share some links later on that sort of go over a lot of information actually, when based on like what sort of works are being done, specifically mostly the open source ones actually. There's a lot of cool stuff that's happening, but right now let me try and open all this. Mm, Getting a lot of prep work that goes into all of this. Trying to find types of roads for a bus scheduling system. Okay, interesting. Yeah, and using different colors for that. That is actually, yeah, that is sort of how it works as well. There are definitely similarities. Okay, now let's actually dive into sort of how the image, almost like cleanup and everything else works. I'm going to move this here, close this. A lot of stuff open right now. I just got off of another stream as well. Okay, that's just not closing. It closed. Okay, I'm still live. Good. Um, so what I want everyone to do first is open up a Jupyter notebook. So you can go to Google Colab or you can do it locally. But open up a Jupyter notebook, and this is sort of where we're going to start with sort of what we're going to be working on. And let me share my screen as soon as this is done. Okay. All right, hopefully everyone's able to see my screen right now. And if not, please do let me know. But what we're going to be starting with is actually something called Earth Engine. So if you Earth Engine, if you look at Earth Engine, which is this right here, you'll see it is a planetary scale platform for Earth science data and analysis. And this is sort of what we're going to be using. So I think this is just a lot of information to actually just all fit into Google Maps, which is why it's sort of not used for it. But this engine right here has a lot of easy, ready to use data sets that have a ton of, historical imagery, bunch of data sets, and over 80 petabytes of geospatial data available for analysis. So this is sort of my go-to, go-to place if I want to do anything using any satellite imagery. I highly, highly recommend it for anybody, right? It is really useful tool. Definitely take a look at it, click around today, later today, whatever. Yes, I can absolutely share the link. It is earthengine.google.com right there. So you do need to sign up for it though. That might take a little bit. It takes up to, I think, 1 day or so, but it should be a lot less. Hopefully you should get it within a few seconds. I know I did earlier, but just go through this. You can click around, see some of their data sets as well. Very interesting stuff. we can honestly just click around for like time lapses around the world. We saw someone was actually in Alaska, right? So you can see one of the glaciers over here actually retreating in real time. And this is using all this sort of satellite imagery data, right? So this is from like 19, what is this, 80, 90 until present day. You can see how, how sort of that's looking, drying of some seas as well. All this, is really, really cool. Time lapses, a lot of cool other stuff also going on. This is a drying of the RLC in Kazakhstan and Uzbekistan. And again, they have a lot of other examples, right? Maybe urban growth, look for something, or coastal expansion in Dubai. That might be a cool one, right? So I think they were expanding their coastline. This is like a time lapse of how that looked and what that sort of looked like. So again, a lot of really cool stuff over here. You can spend hours over here, just completely waste time. I know I've definitely spent a few hours here as well, but we are here specifically for the Earth Engine. So again, if you go down here and hit sign up now, where it says ready to be part of the solution, then you want to register a non-commercial or commercial cloud product. And then you just want to hit unpaid usage because we are just doing training. So you can do trainer and trainees, right? We're not selling this. You can either create a new one or existing one. Either one works. I could do this, for example. And then just create the project. So someone asked, settings for the Colab runtime will be using the service in the app, so I need to sign up, or is it just for fun? I would say it is pretty important to use Colab. We are going to be using Google and like our Google Drive and everything as well for this. So I would recommend at least logging into Google, and you can connect a runtime as well. We will eventually be using the T4, but for today, I think just the CPU should be enough. Does that answer your question? So yeah, you just want to connect to a hosted runtime, then you can like, let's say print hello world as an example, and then it should run. And as long as you got this much working, then everything should be good as of now. Oh, the Google Earth Engine, yes. You will be needing this app. It's not necessary, obviously, you can just look, watch, but I would recommend signing up for it. Again, it is free, you don't need to pay for it at all. So, no harm, no foul. I would say definitely do sign up for it because this is where we're going to be getting our data for that we're going to be actually pre-processing today for basically the rest of today. So it's going to be, interesting. So once all this is done, you can just hit confirm. Then it should take you to some page. Let's wait for it. It's going to be like a big dashboard. I did use an existing project. You do not need to. You can use, however you want to use it. You can create a new project if you want. I just used an existing one because I had an existing one ready, but again, no need. Yeah, if you do want to try switching to a GPU, you can go to the notebook settings. And again, there is no guarantee it'll be available, but it's worth trying if you do need to use the GPU. All right. I'm just gonna wait for a few more people to get access to the Earth Engine. So if you are able to see sort of this page right here, please do let me know. That way we can keep moving forward. I just don't know how long it'll take for everybody. Okay, we got some people that were able to finish. That's great. Just waiting maybe on like one or two more confirmations before we keep going forward. Okay, we have a few more people that are good to go. All right. Okay, now what we want to do is go back to our collab instance over here. And instead of printing hello world, what we actually want to do is actually use the Earth engine, right? So to do that, what we want to do is first of all, authenticate. So you can see if we actually try importing it, import EE and EE.initialize, you'll see we get an error that we need to actually authenticate first, right? So using Earth Engine authenticate, we can put that code up here and make sure to put an exclamation mark in front of it. This basically tells Google Colab that you're trying to run this in the terminal. And running this will tell you, hey, please give me an auth token. So that's going to be, if you click on this right here, this link that it gives you, that'll give you the auth token that you're looking for. I will drag that off the screen and get my auth token. So you try not to click use read-only scopes. It does give you a ton of warnings and everything, but you just want to generate a token. And then it should give you access to that after you allow it to get you everything. I'm going to use my old project for this. Earth Engine project. Generate token. Choose the account that I'm signing in with, and then continue. It says Google hasn't verified the app, even though it is a Google app, which is kind of strange, but it is Google's app, I promise. You do need to allow it to get access to everything. Then it should give you an authorization code. And that's all you need to use. My collab screen is like 240p. Okay, let me try zooming in a bit. That obviously doesn't actually solve the problem, but might make it slightly easier to read. Let's see, zoom in a bit. Hopefully that's maybe a little better, a little more legible. Don't know if you can, but yeah, let me increase the font size from here actually. 20 and again, you just want to ask the verification. What scope should we choose? Don't choose read only, so just leave it unchecked. Okay, this is my auth token, got saved and just got exposed to everybody. That's totally okay. Importing EE and initializing it, and you can see now that it actually works. Let me hide output. There we go. So you can see that initialize works now. All right. All we did here was initialize our Earth engine script. And you can see that we currently have no tasks active right now, which is exactly what we're looking for. Okay, then what you want to do is actually define your area of interest. So what area are you actually trying to get the information of? So I'm going to put in coordinates for, let's say, Austin, Texas. But again, you all can use any coordinates that you all would like. Austin, Texas coordinates. Then I have no idea what Austin, Texas coordinates are. So let me copy paste this and ask Google. Okay, so Google gave me, oops, this for the coordinates of Austin, Texas, but because I want something, a little looser, what I'm going to do is put in uh, Austin chords is ee.geometry.rectangle. And then this is basically getting a rectangle coordinate of Austin. So again, it's going to ask for 4 coordinates to make a box. So in this case, we can go with what 97.85, for example, 30.15, and then you can go up to 97.6 and 30 point, let's go with 4.5. Okay. And it's west, not east. So negative. Okay, there we go. So these are the coordinates right here for Austin, Texas. And then we're just gonna have that run, and then that should save, and everything should be good. Okay. What scope should we choose? How did you get the token? Okay, so the token I got from this link right here. So you go to earthengine.google.com, and then you just need to click this last button right here, sign up now, where it says ready to be part of the solution. And then you need to go through the whole sign up process. Then in here, you put Earth Engine Authenticate in your Google Colab. Then it should ask you for the output, and it also gives you a link to click to get that auth token. So you'll click that auth token link, or that link to get the auth token. It'll take you to a separate page where you just have to go through a few steps, and then you should be able to get your token from there. All right. So again, these are like the loose coordinates that we're using for Austin, Texas. And then what we actually want to do is get the images for Austin with sort of a cloud cover of maybe of a lower cloud cover, because we don't want a cloudy photo that makes it very difficult to actually analyze what's going on, right? Because everything just becomes more fuzzy, or it just becomes completely whited out and you can't see it at all. So in this instance, we are going to actually explicitly ask for images that have a low cloud cover. So for this, we can actually just do Sentinel images and e.image collection. Let's use S2 harmonized. I think SR got deprecated. So we're using Copernicus is one of their image collections of the Google Earth Engine. And then we're using filter bounds for the Austin coordinates. Then we also want to filter the dates. We want relatively recent date. We want relatively recent images, so we can ask for, let's say, images in 2023. They should have 2023 01 01. And then let's see 2024 as well. 2024 01 01. There we go. So in this sort of range. And oops. We also want to add another filter again for the cloud coverage. So the way this filter is going to work is dot filter by filter filter cloudy percentage 20. Let's change that to 10. And then sort by cloudy pixel percentage. You don't even need a true here. And then we just want the very first image that comes up. And then for the band visualization, we just want to have RGB values for it, right? So for that, we can get RGB image is going to be sentinel images that select B4, B3, and B2. Okay, that looks correct. Image slash good. All right, let's try running this. Indentation error. Oh, there we go. Okay, now this is basically just defining what sort of images we actually want to get from from the image collection. So we can actually search this up if we wanted to. And this right here is S2 harmonized. There we go. So this right here is the data catalog that we're going to be using. So it's been available for a while again, right? But this is just a quick overview of what it is, right? High resolution multispectral imaging mission supporting Copernicus land boundary studies. And then this is just sort of an example of how it can actually be used. And this is in Colab specifically, right? So we're able to get this, but again, if you want the full data set, it is right over here. And let's see if there's anything in the chat. Okay, it was looking pretty good. So this is how we called it. These are some tags. So in the meantime, I'll just wait for everyone else to get this and select this right here. So just let me know when you have gotten this sort of image definition done. And then we can move forward. So again, we are getting the image collection from here and actually filtering out what specifically we want. So using this boundary that we created earlier, we are getting a very specific sort of location. And again, it can be anywhere you want. It does not have to be Austin, Texas, obviously. It can be pretty much anywhere in the world, as long as it has some, let's say, tennis courts for as an example. And then you just want to add the date filter, the filter for how cloudy it is, and then sort by that, and you want to get the least cloudy the least cloudy photo out of all of those. So once you've gotten that, do let me know. It's getting kind of quiet. Let's play some background music. There we go. Okay, we got some people that are done. Wow, right when I start the background music. Okay. All right. In that case, as long as we have at least one or two people that are done, we can move forward. And again, if you aren't already, it should still be up on the screen, so do try to catch up. But now what we actually want to do is grab this image, and we're just going to save it to our Google Drive, actually. All right. So let's do that using this function right here. And this might take a little bit because it does take some time to retrieve this specific image from this data set, right? So it'll take like up to maybe 10 or so minutes. Again, it's a very time consuming process. We went over that earlier, but it should be done before the end of the hour. So in this case, we want to get a batch export for this specific task of the image dot, and then if you write to drive here, to drive, that'll just save it to your Google Drive under a specific folder. So very, very useful thing to know actually for any image, any work that you do on Colab. Image is going to be the RGB image, right? Then we want our description to be, let's say, Austin tennis courts, maybe. Tennis courts as an example. And then folder, sure, we can name it Earth Engine. Region is going to be in Austin coords. We do not need coordinates, just the geometry. So region is going to be this, scale of 10, and then we don't need a max pixel value. All right, so this is sort of the task that we have set for the Google Earth Engine, right? So if you go back to actually the Google Earth Engine and right here, ooh, not this one, right here, you can see that there's a tasks tab right here. So this is what we're going to be working in. This specific tasks tab is going to be where we are executing our task over here that we have described over here, sorry. So we're just exporting an image to our Google Drive from there. And all of that in just this many lines of code. Very efficient. All right. And once you've done with that, then you want to actually start that task. So task.start. All right, and this will actually begin executing that task. This did not work. Task.start because what is this image collection asset Copernicus S2 harmonize is not found. Huh. Harmonize, that'll do it. It's harmonized and not harmonizes. Okay, and then we can rerun this and then hit task start, and now the task has started. Now, in order to see where the task is at in our current execution, we can actually print the task status. So let's do print task dot status. Ooh, there we go. And this will say, okay, it's currently running, highest priority, which gives us all the other information about it, right? So this will take a little bit of time. And really, you need, in order to know whether it's done or not, you'd go over here and check the tasks. I think I'm in the wrong project right now. Change cloud project to the default Earth Engine project. And then if I try refreshing this, you can see that this is currently running, right? The submitted task is running right now. It's been less than a minute right now. Average time it usually takes is around 3 minutes for each task. So We'll give that some time, and again, we can just keep on honestly spamming the print task status to see where it's at. And then when it's completed, then the task status will say that it is completed. Put the music on again. Okay, so while we wait for that, just want to make sure that no one has any questions. Everyone is able to get this working perfectly fine, correct? Just want to make sure that everyone's on the same page. No one's falling behind. Let me actually scroll up a little bit so you can get all the other info as well. There we go. Warning, forbidden with reason, permission denied when you try task.start. Did you accept all the everything it asked you to accept? And were you able to run the authentication for Earth Engine? Yes to both. Okay, interesting. If you're still not getting permission, that is very interesting. And you use Copernicus S2 harmonized? Trying to think what else it could be. That's correct. I don't want to rule in location just yet. Let's see. Are you able to make searches over here? Or harmonized? Were you able to search over there? Just for like harmonized, multispectral, anything? Copernicus. It could be an OAuth issue, but the key, if it might just be like the way you pasted the key. Can you make sure that the key that you pasted was correct? Might have missed like a character or two. If not, then that's another, I guess, a deeper issue that will take a little bit more time to actually figure out. Check the box for read-only scope. Yeah, that'll do it. Okay. Perfect. All right, glad you were able to get that resolved. So now you can see, actually, I just ran the print task status again, and the state is now completed, and we have all of this information about it. So what you then want to do is go to your Google Drive, actually, and you should be able to find a folder in your drive with the name. For mine, it's going to be called Earth Engine. For you, it might be named something else. So you can see over here, I have this specific .tif file in my Google Drive. And let's get file info. You can see it should be around 43 megabytes. If you use the same information or the same coordinates as I did, you might have used different coordinates, which would give you a slightly different size, but it should be a fairly decent sized file. All right, so just make sure that all that runs for you. Then you just want to download it. So this is what Austin tennis courts. I'll just download that. And it should end up downloading over here. It might take a second to scan for viruses. And there we go. It's done downloading. It's called austintenniscourts.tif. All right. So I have that downloaded. Now we can move on to the next part. And this next part is going to be pretty fun. So just want to make sure everyone's up to speed. Everyone's done. Okay, good. All right, for this next part, we're actually going to be using this very interesting tool called Overpass Turbo. And it basically does essentially what I said that, you know, you can have Google Maps sort of do, which is get a lot more information of basically what's going on in a specific area. Okay. If it's still running, that's totally fine. It might take up to, you know, 5-10 minutes for it to finish running, but uploading TIF. We are not currently uploading anything. We're just going to be going straight to this Overpass Turbo part. All right, looks like we're able to get it working. That is awesome. Okay, so this right here is a really interesting tool that, okay, so people do know Overpass, that's great. Very interesting tool over here, which is really actually useful for image segmentation, right? What this is going to do is basically give us very defined, almost overlays of where what we're looking for is. All right, so we can actually see an example of that. So we're just running straight with our tennis, excuse me, with our tennis specific example, right? We can see, if you look at like the help, this will give you a lot more information about it. Again, very cool, very interesting, very easy to use app, but they have this thing called the wizard, and we're going to use the wizard because we don't want to do any scripting in here, right? So over here they give you some examples over here, like drinking water, highways, tourism, or like you can also add specific locations, right? So what I want to look for is specifically tennis in Austin, right? It could be tennis, it could honestly be anything else. It could be like football, it could be basketball. But let's see what happens if we put tennis in Austin. And then we want to build and run this query. So it calls this Overpass API, and it gets all of this information. It says, okay, this Overpass Turbo Wizard made all this, and all it's doing is fetching the geocode area of Austin to search in, and then it's gathering all the results. So within this search area, look for any pitch with this specific sport. I translated it to paddle because you can see the .eu extension after overpass-turbo, right? .eu, not .com. Let me actually send that link. I think I did not do that. So again, it is a .eu, so I think it just translated tennis to paddle. But again, if we try running this right now, we'll see that it gets 0 results because the sport in this case is paddle. Just want to change that to tennis. We can run that again, and we should get a few more results. And yeah, you can see we got, wow, 565 results just from that simple query, right? And then if we zoom in a little bit, let's go to, I don't know, somewhere in Austin over here. Zoom into one of these red dots. There's a ton of them over here. You can see that there's something called a Texas Tennis Center, which expectedly would have a ton of tennis courts. That's exactly what's going on, right? It's got around 12 tennis courts just right here. I did notice though that this does sometimes mislabel some tennis courts for others, right? So you have like tennis courts, you also have like pickleball courts, for example. Those do also get considered tennis courts by this occasionally. So that is something to look out for. You won't get a completely perfect result, you might also get some incorrect ones. So I think over here, there's like some pickleball courts on the side, for example. And then you can see like the standard sized tennis courts, all the same size, right? Then you go here, you see some smaller courts. I'm pretty certain these are for pickleball and not necessarily for tennis. So that's just an example of sort of how you can get all of this sort of information out of it. All right. Again, very interesting stuff. So it is, again, the top of the hour. I think now is a great time for a break. I would recommend just clicking around here, trying to figure things out over here, figuring things out with the Google Earth engine, playing around with that as well, or just grab a drink of water. That is what I will be doing. And then we can reconvene in around 10 minutes. Okay. So 10 minutes. We'll be back here and continue the rest of the stream. All right. So until then, I'll be grabbing some water. I recommend you all do as well. Yeah, I'll see you all in 10 minutes. All right, it is 9:10 p.m. on my side. It might be a little earlier or later for you, depending on where you are. Um, and time to get back to it. So, I could see that some of y'all were able to get it working and are all caught up. That is great. I am very happy to hear that. And we do have some new people that are joining us as well. Hello, hello. I am so glad you can make it. Okay. Um, So we left off with at overpass turbo.eu, right? And you can see here that sort of um, the tennis courts that it's looking at, yes, the Austin bubbles, the tennis courts are sort of all over the place right now, right? But again, we have a very specifically defined bounding box that we want to make sure that this stays inside of, right? We already defined that bounding box earlier the in the code, right? So that was 97.85, 30.15, all this right here. So what we want to do is basically convert this over so that the overpass turbo also gets that specific info. And then instead of this looking like a big blob of Austin bubbles, as was said in the chat, it looks, it should resemble more of a rectangle. So that's sort of what we're going to do next. And that should be pretty simple. All right. So in order to do that, we are just going to, first of all, erase the sort of geocode area, right? Because we don't really need this. We just want a bounding box around it. So we have NWR leisure is pitch and sport is tennis. Now, instead of this area being search area, we just want to change that to 30.15 is what we had earlier. Negative 97 west 0.85, and then we had 30.45, and we had 97.5. Oh, close this out geometry. Okay, so you can see right now it looks like a blob before we run this. Now after we run this, it should resemble more of a rectangle. Okay, and yeah, that does resemble a rectangle a little bit more, just as we expected it to. So you can see there's sort of almost a hard cutoff over here and over here. Over here it looks a little bit looser, but that is also because there is a lot less going on this side of Austin. We do see like a school that has a few, but other than that, not too much. So that is perfect. That is what we are looking for. Can I make the text bigger? Absolutely. That is not how I make text bigger. Let me try. Okay, I just zoomed in a little bit. Hopefully that's legible. um, so again, it is just giving the output in JSON a timeout value of 25, and then we're just using the area of Austin to search in, but we erased that part. We're just doing NWR leisure equals pitch and sport equals tennis with these specific coordinates. All right. And once you have this, again, it is 30.15, negative 97.85, and 30.45, and negative 97.50 as the rectangle in which we are working with. Okay. And once we've gotten that working, we actually want to export all of this. Okay, so we just want to hit export over here, and we actually want to download it as a GeoJSON file. So we just want to hit download over here, and that should give us a download. It might have another one from before, but it should be called something like export.geojson. All right, so it should look something like that. And it shouldn't be too big of a file. It should just be a few kilobytes large. And if we actually did want to see what it looks like, we can. and it is basically a JSON file with a bunch of geo coordinates. So if we see that, so again, it looks something like this, where it's just a bunch of features saying, okay, this is where the data is from, nothing that we need over there. But over here, it has all the information about the geometries specifically, right? Because we are using polygon geometry for all of this, it is not a bunch of blobs. We're using sort of straighter lines to actually define where what we are looking for is. And this is just giving us all that sort of information, right? It's a specific feature, the geometry and the coordinates of that geometry. And that just keeps on going for the rest of the file. All right. Let me go back to my screen, and then I will first need to figure out what I need to share. Okay, there we go. And yes, I can absolutely send the coordinates in the chat. Here you go. Here are the coordinates, and the check-in link I did send. Oh, okay. Thank you. We got the check-in link there, and these right here are the coordinates. Okay, so hopefully you should have the coordinates now. And again, your map should be looking something like this. Now, this next part is a little bit of a time-consuming one, but that is because you do need to download something else. Normally, I don't like having, having to download anything external on the stream, but it is a very powerful app, and it is, extremely useful, especially if you're trying to do more of the sort of image segmentation or sort of analysis or any sort of layering with any of this stuff. So I do highly still recommend you get it if you are interested in sort of going deeper into this. But again, if you don't want to install it, you don't have to. It is totally optional. That's why I have sort of just this section for today, where we're going to be we're overlaying these images or these polygons onto the image that we had from earlier that we got from the Google Earth engine. But tomorrow's stream, we're going to be doing something basically starting from scratch, so that you don't need to download this app if you do not want to. All right. So what we're using is this QGIS, all right? And this is basically a way of sort of doing all this spatial uh, sort of image recognition and all that sort of stuff all in one place. It is an insanely powerful tool. If you are, if you do know how to use it, it's, it's great. It is very useful, especially if you're trying to do anything in here. Would recommend you all definitely take a look at it. Okay, it looks like some people do have experience with QGIS. That's awesome. It is taking a while to load on my end. I think I do have a lot going on my laptop right now. But yes, this is sort of what it looks like. We are going to be downloading this. So again, it is just a spatial visualization tool. Super useful, very, very powerful, right? Make maps. It has a bunch of other uh, pretty cool features where you can edit layers, do other digital stuff. We're going to use it for something a lot simpler. Again, this thing has an insane number of features that you can actually take advantage of. It's like the Photoshop app basically for maps, right? You know how Photoshop has so many options that you can barely know where to get started when you first start off. It's something like that. And the great thing is it is all open source, unlike Photoshop. So what we are going to be doing is downloading it. Again, it is Photoshop, or sorry, it is open source. So um, I know that makes some people a little bit less nervous about downloading it, But again, it's going to ask for money. You don't need to give it any money. Just skip it, go straight to download. And wow, my laptop slowed down. There we go. I'm just going to get the latest version. I think the long-term version is slightly larger. So I'm just going to get the latest version. Native support. Do they have native support? Oh, you can also download it for Windows if you want as well. So Windows downloads over here. Linux, if you're on Linux. They also do have a mobile and tablet version. I don't know if I would recommend doing all this on there. It's got a lot to do. It's got a lot of features, but definitely you can take a look at it. Okay. So what we're going to do is download it, and then we're just going to wait for it to finish downloading. This might take a little bit of time because it is a pretty large app. So 1.6 gigs, about another minute left. Hopefully my connection to you all doesn't drop in the meantime on StreamYard. But this is essentially what we're going to use to layer things on top of each other. So we have the TIF image that we got from here. And honestly, we can go to like I don't know, TIF image viewer online. And then if we upload that here, we can actually see what it looks like. So let's do that because why not? So this right now is uploading. Uploading. Wow, upload and download at the same time. I'm stressing my Wi-Fi out. Okay, so if we view the image here, you can see it should just be one large block of an image that's really high quality in terms of just satellite imagery. So this is what it looks like right now. You just want to zoom in more and more until you can actually see something. And there's some issue with the brightness on this. But that is why we are downloading QGIS to fix all of that. But that's interesting. Did not think it'll end up looking like this. Okay, well, we've gotten this installed. Now we just need to open it. And then it'll probably ask us to drag it into our applications folder. Sounds like cleans glasses. Yeah. Yeah. Yeah, very difficult to see. And then, okay, yours is also dark like that. That is good. That means it is, I guess it's doing what we are expecting it to do. So that's good. So once we open up this, the file, I'm opening it up on the side. Just make sure you accept all the, terms and agreements, everything. It is all open source. So if you do have an issue or you're scared of what they're doing with your data, you could always go through the code. And right now, we just wait for it to open up. It does take a little bit. It's going to verify this, then I'll probably have to download or drag it into my applications folder. So that's also going to take a while. But that's okay. We have some time. Yeah, what's all of your progress looking like so far on downloading this? Hopefully your internet is a little bit faster because you're not oh, okay, done. I think DatPep, you had it from before too, right? Opened, ready to go. I love that. Already had it. Awesome. What were you using it for? Just out of curiosity. Because I don't know a whole lot of people that do use this on like a daily basis. QGIS 3.38 greenable. Oh, this was for the bus scheduling system that you built. That's awesome. Okay, that's really cool. That means you've been through all this before. That's amazing. Love to hear that. All right, and this is still verifying. I have a loading screen here. It is maybe 70% of the way done. Oh, I have two loading screens here. One is around 80%, one is 90% of the way done. Okay, ask me to drag this into my applications folder again. Let's do that. And that looks like it's going to take a while as well. About 3 gigs. Okay. Is everyone else also in the process of installing it or downloading it? I will take that as a yes. Everyone's very busy trying to get this in. All right, yeah. So it's going to take a little bit of time, but again, nothing to worry about. Opening, awesome. You all have much faster internet than I do. All right. In the meantime, it's really interesting to think about sort of other applications that can also be used for this, right? You don't even need to use sort of the existing data sets of like that already exist on the Google Earth engine. You can honestly, if you have like a drone, for instance, right, you can honestly just create your own. I actually did have a drone earlier, and I would just take a bunch of pictures of like, the ground floor, and I didn't use them for anything, but looking back, you're like, okay, I could have taken these specific images for this purpose and honestly done something very similar to what we're doing right now on a custom built data set. And it could be on something on a much smaller scale as well. It doesn't need to be like you all the way up in the air at where, however high most of the planes that have the cameras on, however high they fly, you don't need to be at that distance. You can actually come down a lot lower and get much better or more detailed coverage of the ground. So it's really interesting actually to see what other applications exist for this type of technology. And if you also have something that also might be pretty interesting, I would love to hear about it. My internet is absolutely bench pressing. It is bench pressing and doing squats at the same time, bench pressing and leg pressing at the same time. It is busy. All right, looks like it's around halfway done copying this to the applications folder. Taking a little bit of time. In the meantime, we can click around actually the Earth engine. You can suggest new data sets. That's interesting. Let's see what other features it has. Okay, this is interesting. You could do line drawing for geometry. So let's say we were in like France, or let's go up north to Switzerland. Let's say we're looking for like this specific geometry right here. Honestly, I don't know what I'm doing right now. I'm just kind of doing anything. Cool. It's bounded by country. Okay, let's bring this back. 10 vertex geometry. You can save this, run this using some profiler. And there's other apps you can actually connect with this too. Cool. All right, let's see what the progress is looking like. About a minute left. Half a gig to go. Okay, almost there. All right. Some background music on while we wait. Honestly, let me share this as well. That way we can all watch this this loading screen move. about 10 seconds. Is that true or is that a lie? 5 seconds. Okay, there we go. It is, I think, finally done. If it opens up. And okay, it is open. That is great. Oh, let me turn the music off. There we go. And remove all these layers. Okay, so does everyone have QGIS opened? And again, if you are on Mac, it might be a little bit difficult. You might have to right click and hit open because it does say, oh, it's from untrusted source or something. So you might need to right click on it on the application and then hit open, and then it'll give you the option to actually open it up because it's like unsigned or something, some issue with it. So do make sure that works. Whose GarageBand is this? This was some preloaded music on my StreamYard, so I'm doing the best I can with what I've got. Let's see. All right. I appreciate everyone egging on my internet. Right click does do that, yes. So this is sort of what yours should look like, something like this, right? Just a white background, nothing really going on here. Completely empty, untitled project. Some information over here on what's going on like in your home page, your home screen. Okay. Now what you want to do is actually just find your TIF file and you just want to drag that in, sort of just to get it opened up. And it should look something like this. And this is really what we were looking for, right? This looks a lot less like one big dark splotch and a lot more like what a city might look like. You have some, I think these are farms or something going on over here, a lot of houses, and some other stuff happening around here as well, right? So this is sort of what we are looking for right now. If you zoom in too much, you'll see that it completely falls apart. It's just a bunch of pixels, right? And that's one of sort of the pitfalls that we see right off the bat is that, okay, the image quality maybe isn't as good as it could be, right? So in this specific instance, you might see that, hey, like some pixels don't look right, right? We have some like outliers, like this random pink one over here that could be there for a reason, but we have no idea or no way of knowing. So this is what we are working with right now. I think this is actually the university right here. So that means the tennis courts should be nearby. And we will see that very shortly, right? But when we actually import the next thing, which is the export from our overpass turbo. All right, so let's do that now. Okay, why can I not find this? There it is. Okay, so I just added a GeoJSON export, and you can actually see that if I unselect the actual photo, I'll see all these random sort of blobs that show up. And if I really zoom into these, you can see that these are actually the tennis courts that we exported earlier. Yeah, so this would be the GeoJSON export of the tennis courts that we got um, from the Overpass Turbo. So you can see that this actually exports all of these sort of tennis courts, and it's all over the place, sort of, right? So you can see we have a few that are way out here to the east. We have a lot of them, and it just looks like a lot of sort of dark spots almost, right? Dark, you know, squares. And that is what is being overlaid on top of our photo over here. So if we actually zoom into one of them, freckles, yeah. So we zoom into one of them, we can actually see that that is exactly where we would expect it to be. But again, it is a little bit more difficult to tell because of the export, the way the export looks. It's very pixelated. Trying to find a few more examples around here. I think it's just hard to see with the color. We should be able to change it though. Let's change the styles to maybe a really bright red color. Okay, this is like more orange, but I think it's still easier to see. So you can see we have like an orange tennis court over here. It does look like my screen got dirty. That is correct. Um, but this is sort of what it looks like. And you can see that we have a lot of outliers still, even with the projection that we gave it, which really we weren't necessarily expecting, but that is sometimes what happens. So you would need to then actually adjust the export for all of that. And you can just click around and see sort of how that looks. And this is essentially really the key component. And you can see why now it's so difficult to do these sort of labeling tasks, because again, you need to go in and actually get each and every single one of these to line up. These are, I think, mostly lined up. It might be missing a few over here, or this might be something completely different. Again, I have no way of telling because it's so pixelated, but it is definitely really, really interesting to see where all of these are. And some of them may actually not be in the right spot. So what we actually need to do is make sure that these are all in the correct spot. So what we can do over here is actually check the properties of each of these exports, right? And if we look at the properties of this, the Austin tennis courts, let me share that. I don't know why it's not showing up. We can see some interesting stuff, right? Like for example, the pixel size here is 10 by -10, right? So that usually means a 10 by -10. I think it's either meters or feet. I'm not 100% sure which. I'm pretty sure it's meters though. So each pixel is about 10 by 10 meters, which is why it's so blurry. Then it just gives a bunch of other information about the actual TIF file, right? And then we also get the projected extent, right? The spatial extent and the temporal extent. So this right here, we want to remember, just because we want to make sure that both of these are the same, right? The export for uh, the TIF file and the export for the GeoJSON. So this is in what, 32614, UTM zone 14N. Now, if we looked at the next export, close this out and check the properties of this. And share that to you all. And add that to the state. There we go. And we can actually see that this is actually in a different coordinate reference system, right? This is in WGS, what, 84 instead of the zone 14N. So we can't just change this right off the bat. Yes, it is slightly different. We can't just change it because that will, that's not going to do anything. And I think that's what, yeah, that's what this is right here. Changing it doesn't modify the original data source or perform any reprojection of the features. It's just used to override the later CRS within this project if it could not be detected or has been incorrectly detected. Usually this is detected correctly though, so what we actually need to do to fix this is project one layer onto the other. And that is what we are going to be doing. So to do this projection, there we go. To do this projection, we need to actually go to the layers. So if you're on a Mac, it should be on the top. There should be something called layer, and you can look at some information over there about all the different layer properties and things of that sort. But let's see. Once you have all of this, you want to go to your layer, and I believe it was in, where did it go? Temporal, no. Symbology, no. Great. One second, let me try and figure out what's going on here. Okay. What we want to do is go to actually raster, and we want to go to projections. Where is that? There it is. And then we can assign a projection either from the raster or from the vectors, right? So we have two options here. I would say it is probably better to do it from the vector over from the raster. So if you go to vector data management tools and then reproject layer, it should give you the option to project one layer onto the other. So it tells you the input layer. Let me see if y'all can actually see that. You cannot see that. So again, there we go. So again, what you wanted to do was go to, again, if you're on a Mac, vector data management tools, then project layer. This should say project or reproject layer, and then it'll give you the option over here. And it's a little bit difficult to see because it's black on black. Don't know who made that UI decision, but again, this is just reprojecting the layer, the vector layer, and we select this one, and we want to actually target the UTM zone 14N, which is the same CRS as the TIF file, right? And then the reprojected layer, we can just create any temporary layer called, I don't know, we can just leave it on its default, and it'll open that after running. So if we hit run over here, then we should get this reprojected layer. And that should show up on the left side. Now, if we take a look at these, we can actually compare the two. They are almost identical, but now they are in the, but now the new reprojected layer is in the same CRM as the original TIF file. Okay. And again, this part is really important because this is also something that goes into it is also something that goes into sort of doing all the pre-processing, right? You essentially get huge amounts of data this way really easily. Then another way of easily sort of getting that data labeled. Again, you're sort of already using pre-labeled data, but in order to label that data, what we did was we got that from the external tool. Then we get the export for that project all of it. Then what we do next is we would combine all of this into one sort of file. We could split it up into multiple parts and then feed that into a neural network to actually define what sort of a tennis court might look like. And then that would give us the output then. All right, so that's is sort of how the entire thing would end up working. And let me actually show something really quickly. Analysis project. Da, da, da. Hmm. Okay, so vector general, I have like random things open in the background. Okay, so again, you should end up with this new reprojected, sorry, vector onto the tennis courts, and you can see the different bands that we actually exported as well from the tennis courts on top of everything else. All right. So now to actually convert this sort of vector data into a raster, which is sort of going to be the segmentation mask that we're using, there are really two ways of doing it. We're going to try and use the sort of automated way. That way we're not, sitting here going through, what is it, 500 almost, 600 tennis courts and just trying to actually mask them all. So what we're going to do here is just use the rasterize tool. So if you go to rasterize at the top, if you're on a Mac, so raster, and then from raster you want to go to conversion, and then from conversion you want to go rasterize vector to raster. Then you actually want to select your input layer. So in this case it would be the reprojected input layer, not the old one. And I am not sharing my screen at all. Okay, so let's do that one more time. There we go. Okay, so what I did was I went to raster, conversion, then rasterize a vector to a raster. All right, and then it should open up something that looks like this. So you want to select your import layer as, or input layer as the reprojected one, and you can set any value you want for burn-in. Normally use like a value of 1 for burn-in that basically tells it to burn everything or burn just the polygons to a 1, and then everything else is going to be set to zeros. And then in this case, you would set the size or the reference units to pixels. We saw earlier that all of these are 10 by 10 in resolution, right? Each pixel is worth 10. Don't know if this is input or not. Okay, so we have the georeference units as 10 by 10. We don't need to really set any output extent or a no data value. And then we do want to say where we or how we want to save this thing. So let's save this to a temporary file. That's fine. Hopefully that works. And then you just want to run this. What this does is it actually converts all of their information into this vector. So hopefully this runs properly. Okay, awesome. No issues. And that basically rasterized our initial vector. If we close that and take a look at it, Where did it go? Interesting. Okay, let's look at the file itself. So, okay, somebody asked, why is it useful to convert vector to raster here? So this is sort of just for direct overlay, right? So that you are um, actually imprinting almost all of these previous exports onto the TIF file, right? That way, when you actually export this and split it up into smaller segments for training, then it's a lot easier to tell what the training values or the locations are themselves. So you can either do it in here if you want, or that can be done in the code using the raw data from the reprojected GeoJSON file and the TIF file. But the TIF file would require a lot more mapping then, so it is a little bit easier to do it earlier on. I do need to catch up on a lot more of the chat. Slightly different. Yes, thank you. It is vector and data management tools for actually checking for reprojection. CRM. CRM is a coordinate reference management. And that is, again, basically just to know that you are in the same almost coordinate space as um, another export, right? So let's say you have this TIF import, right, which is the image that we have on the background of the satellite image, that you want to make sure is in the same coordinate plane or homed into the same coordinates as what you might be using with the GeoJSON export, for example. So if those aren't aligned, then like one might be in, I don't know, like South America and one might be in North America, right? So you want to make sure that they're in the same place. That's sort of what the CRM is for. And yeah, it is a heavy application, so it does take some time. Oh, looks like it did get answered. Thank you, DevPep. Um, so that's what did we do? We just converted everything. We just rasterized the projections, the projection. So that's not terribly important. Again, all of this was just really a demonstration for sort of what the process is that a lot of these almost research scientists have to go through in order to get to a final product that they can actually go into for training, right? So again, the actual pre-processing of the data, all the cleanup, all of that stuff that we just went through this entire stream is essentially what others also have to go through in order to get there. And then someone asked, what was our resolution? What do you mean by our resolution? For the rasterize, it was 10 by 10 for the coordinate plane because each pixel we saw earlier was 10 meters or 10 feet, some 10 units to per pixel. So that was the resolution input. Now I am running low on time, so I'm going to say we should about wrap it up. I'll answer any other questions that anyone does have. But again, just as a sort of conclusive remark, this whole sort of experience was to really understand the process that a lot of, again, research scientists need to go through in order to do any sort of geospatial data analysis, right? So we did a whole lot, right? We actually went and started with going to our Colab notebook and we sort of authenticated our Earth engine. We got our Earth engine up and running. We got the coordinates and created our rectangle geometry. Then we got our specific TIF image from the S2 harmonized data set from the Google Earth engine, right? And I do recommend you all click around in Google Earth engine. It's a pretty cool tool. Then we went to Overpass Turbo and then got very specific sort of data on tennis courts that were in Austin, Texas. And then we used QGIS to basically overlay the two onto each other and then almost fuse them uh, right? Uh, and then that fusion of them is basically what we would then have fed into another model. So again, a lot of this was, I think, very complex stuff. I'm really happy that you all were able to make it this far. The next one is next stream. This is a part one. Part two is going to be almost a sort of reset where we're going to be starting from almost the beginning, but you're going to have a lot more background knowledge on sort of what goes into getting this sort of data, what goes into getting this sort of information. And the next one's also going to be very interesting. Highly recommend you all join. It is going to be tomorrow for me. If you want to know the exact time, you can also go to in your location, you can go to the Global Hack Week schedule and check that out as well. Takes 28 gigs for you. That is insane. 28 gigs is a lot. And then someone said that Bellingcat has a cool open source investigation toolkit. That could be pretty cool. Yeah, definitely go check out anything that you need to. All right, I think that is about all I have for this stream. Again, next stream is going to be more interesting. We're going to be building a lot more stuff. So definitely recommend you all come out to that. And again, if you were at this stream or you were at my previous stream, I do ask that you fill out this link right here, mlh.link/GHW or Global Hack Week feedback. I think Major League Hacking is, I think, just looking for feedback on how the streams go and how they might be able to be better. So I'd appreciate your time if you could fill that out. And again, I'm here if you do have any other questions for a few minutes. I will also be, if you were again in my previous stream, I'll be publishing the GitHub for that in the Discord. And yeah, that is about it. Again, thank you all so much for coming. And I will hopefully see you all tomorrow at the other streams. All right, bye-bye. Next session is 7 p.m. EST or 2 a.m. Cairo time. All right, I'll see you there. 4 a.m. GMT. All right. Hopefully, I will be seeing everybody there, no matter the time. You can still make it. That's awesome. All right. Again, I do appreciate everyone who came out coming out. Do fill out the form if you have a minute. And that is about it. All right. Bye bye, everyone.